Hi, in this video we are going to take a look at the bake settings of the vector field viewer as well as the import and export dialogues. So first thing, the bake settings, it's this panel down there, and this is what allows you to control how the vector field will be baked for runtime use when deploying to the game engine. So you have two controls you can change here. First is the source axis system. So this is also used by the PopcornFX editor, by the way, to preview your effect when you are editing it. So the source axis system defines in which axis system the vector field was exported, because the FGA format doesn't allow to embed metadata where the axis system could be specified. So depending on if you exported it from Maya or Houdini, for example, it won't be the same axis system. Typically, vector fields used in Unreal Engine are using the Z-up coordinate system. Here I'm in a project which is using a Y-up coordinate system. So specifying this tells Popcorn that this is a Z-up vector field, and it will internally flip it correctly so it works in my Y-up project. So you have access to various axis systems here. The re-import button is here just so you can, if you hit it after changing something, it will rebake the asset and you will see it update in the viewport. It doesn't automatically rebake when you change things. So here, for example, if I switch from FP16 to U8SN, so this stands for unsigned 8-bit signed normalized. The unsigned signed doesn't necessarily make a lot of sense, but that's what it is. It's basically an 8-bit vector field, so much less precise than FP16. So if I choose that, and if you look at the vectors here while I'll hit re-import, you will see them very slightly change. Yeah, it's a very, very slight change. You might not even see it in the encoding of the video. If I pick one, this should be easier to see. If I go towards the end here, so this is using FP16. If I switch to 8-bit, here you can see the vector, just the path just changed. So it will mostly give the same vector field, except for very slight differences in precision, but it's also much smaller. So here, for example, in FP16, my vector field here is taking 1.5 megabytes of memory. And if I switch it to 8 bits, it now only takes half of that. And if I use the full precision 32-bit floats format, it takes 3 megabytes. So 4 times as much as the 8-bit. So that's basically it for the bake settings panel. It's just a way to tell the Popcorn runtime how it should import the FGA file and how it should store the vector data. So now let's take a look at the export dialog. So you have those two buttons in the toolbar, which are respectively import and export vector field. You can also use the Ctrl-Shift-I and Ctrl-Shift-E shortcuts, or go to File, Export and Import. So here I'm going to hit this button. It will ask me where I want to save the vector field. So here I'll just pick the name of a new FGA file, and it shows me the export dialog. So here I have a couple things I can set up. The file format, I can export that as a texture instead of FGA. We'll see that afterwards. The resolution, so here I can change the resolution of my vector field, upscale it or downscale it. The bounds, so these are the world space bounds of the vector field. So here you have a 10 by 10 grid in the viewport, and the vector field goes to from -8 to 8 world units, so 16 in width, height and depth. And you can also flip the axis system if you want to save it in a different axis system. These are for animated vector fields, we'll see that afterwards, and you have a couple other options we'll also see afterwards for animated vector fields. And here at the bottom you have a recap of what it will produce with those settings. So here the baked resolution will be 64 cubed, and these are the different sizes of the final baked asset for each of the different formats. You can import them in. So as this writes an FGA file, you have the size of the FGA file. It's FGA are text-based formats, so they're much larger than the baked assets. And as this just writes an FGA file here, that's why you have the 3 different possible sizes depending on how you will import it afterwards, because this export dialog doesn't know how you will bake it or import it. So here, if I just hit export, now I should have this new vector field here, which is basically the same as the previous one because I didn't change any settings. So here we can see that it's same resolution and the baked size isn't the same. That's just because the new vector field by default doesn't have any well, it has the default values for the bake settings. So those bake settings, by the way, are stored in a pkcf file, which is an additional file next to the vector field. So here I have that one, that FGA file, and next to it you will see that pkcf file. And if I open it, you see here the settings for the bake settings, the U8, SN, and left-hand Z up. And this new one doesn't have any. So let's say I use it as U8SN as well, and now it creates the pkcf file. Just a small precision. So I'll switch to vector so we can better visualize the resolution, and I will re-export that vector field onto this one. And now I will change the resolution to 16, so I see the sizes update. Now it's only 12 kilobytes instead of 768 kilobytes. Hit export, and there I have it. Much lower resolution, and if I display the vector field as path, you can see that the paths are pretty much identical, even if we divided the resolution by 4. So now let's see the animated vector fields. I will open that one. Here if I hit export, let's say I'll just pick the same vector field actually. So here I'll just overwrite the vector field I just created previously, but now it's animated, so I have access to first frame and last frame, so I can choose a range of frames in the animation that I want. So let's say I don't like the beginning of the animation and I just want to export the end. So here I pick my start and end frames, hit export, and as you can see now I have the frames I chose here, except the vector field is now much smaller than the one I had before, which was a 16 in width. So this one is now 2 meters in width. So I can also change that in the export dialog. And let's say I want it to sit on the ground plane. So I'll set to 0 here and 16 here. And now I have changed the world space bounds, which means basically the vector field is now much larger. You can also change those bounds when you sample the vector field directly inside the effect, but it can be useful to pre-scale it in the asset itself, so that's how you do that. So another useful thing you can do when exporting is to actually export an animated vector field to multiple frames. So here I'm going to do just that. By default, it will write a single file, single FGA file containing all the frames of the animation. The way we store that file in PopcornFX isn't really supported by any other software I'm aware of. It's just a trick we use to store animated vector fields inside a single asset, and basically we have the standard FGA header followed by the dump of all the vector data of all the frames. So if you had 16,000 vectors and 10 frames, you'd have 160,000 vectors in the FGA file. So if you want to use those FGAs in another engine or software, for example, if you want to import them into Unreal, you will have to check the export each frame to a separate file checkbox. And now this shows you all the frames it will write as separate files. You can see that it changed the file name here based on this pattern. So I have $filename means the original file name. $axis system is an encoding of the axis system. So here I'm in right hand Y up, which is right up and backward as absolute axis. So this spells out rub, so VF rub. And then I have the frame ID, which is a zero-based, the zero-based index of the frame. So let's say I don't care about the axis system. I can remove that, and now I only have VF and the frame ID. So I export that. And now in the animVF folder, I have all the frames dumped. Each one of them is a single vector field, which I can then grab into the software of my choice. So let's see another option there. You can export FGA files, but also texture files. So some engines do not support FGA, for example Unity. Well, at least not as a built-in. You might have some plugins that support FGA imports. So here we also have the option to export textures. So let's say I do an animVF folder here as well. I will save it as a texture named VF. Here you can change the extension and choose different texture formats, for example PNG or TIFF. Note that if you change the texture format here compared to the one you picked in the Explorer window, you will also have to change the extension. If you don't, you'll simply get a warning about a suspicious format telling you that the extensions are mismatching and that you need to patch it. So here I'll keep DDS. You can also change the resolution. You cannot change the bounds because we cannot write vector field bounds inside a texture, so it makes no sense. You can set up the frames. Now when exporting as a texture, you will see this option here, and this allows you to save the volume as a 2D texture instead of a volume texture. So this is mainly useful for formats that do not support volume textures, such as PNG, JPEG, and here it will activate it by default. But here I will keep DDS, I will keep the FP16 format. So when you pick one of the 8-bit formats, it will not store the actual vectors, it will rescale them, it will normalize the vector field based on the largest absolute component of any of the vector in the vector field, and it will remap that between 0 and 1 so it fits in the 8-bit format. But here I'll keep FP16 and I will just hit export. So now If I go into my NMVF folder, I will have all my textures for all the frames exported here. And of course, if you open a non-animated vector field, you can also export it to a texture. And when I double click on the vector field, this opens the texture viewer, which is a new viewer in 2.6 as well. Make sure to check out the video dedicated to the texture viewer. And here I can scrub through my 3D texture to inspect all its slices. But unfortunately, this will not allow you to export a vector field for, let's say, Unity, because Unity only supports natively vector fields or volume textures that are in a tiled 2D texture format. So here you will need to check the export as tiled 2D texture checkbox. Let me just remove the frame ID here. So when I do that, here I have my entire vector field saved as a 2D texture, with each tile being one depth slice of the original volume. So you will note that this is a floating point texture here, saved in FP16. You can see here when I hover, I pick this texel here. Here you can see that the actual values are negative. So let's say you want to export an 8-bit texture instead, for whatever reason, such as your engine doesn't support floating point formats, or you want to save into a format that doesn't support floating point formats. So here in this dropdown, in the pixel format dropdown, you can pick one of the 8-bit formats. Here I'll just pick PGRA8 and I'll save it, let's say, as PNG. Hit export. I need to change the extension. Export. Right, and now when I open this texture, you will see that it looks pretty different from the previous one, and we now have, where we had negative values previously, we now have normalized values between 0 and 1, with 0.5 being the vector 0. So when you load and use this texture, you will actually need to remap 0, 1 to -1, 1 to get the correct vectors. So there you have it. This is how you export vector fields into textures, both volume and 2D textures. So now let's see how to import a vector field. This will be the first step you'll need to take to import an animated vector field. You have a much quicker video that you can look at specifically for doing this. Here I'll go into more details about the different options. So to import an animated vector field, or a vector field, to import a vector field, there is no UI option in 2.6.0 yet. So you have to create manually a vector field or duplicate an existing one. In the other video I was talking about, I just created an empty text file that I renamed to FGA. Here I will just reuse that one, and I will import another vector field. So let's say I go into the NMVF folder, I select all my frames, and this brings up the import window. So here you have the list of all the different FGA files you are going to assemble. This can be a single FGA file if you're just importing a single file and you want to just change the resolution or the bounds or whatever. These are the same controls as in the export dialog. So when you import a single file, just to change the resolution or the bounds. It's basically the same thing as if you exported that single file in another file and changed the resolution and the bounds. So it's pretty much whichever you prefer. But so here I have all my frames. This is just a shortcut to say which frame range I want. So this is pretty useless when you are using single files, but it's very handy when you are assembling multiple animated files, which we'll see right after. And then I just hit import, and here I have my new assembled vector field. So let's say we want to do something a little bit more complex. So here I'm going to assemble, let's say, this 8 by 8 by 8 by 16 frames file and this 16 cube by 20 file and the roto wash. So here I have my 3 source files. I can see that these two have multiple frames. Here it tells me that the resolutions are mismatching. I have 8 cubed, 16 cubed, and 64 cubed. And here it will take the properties of the first vector field in the list. So here by default it will output an 8 by 8 by 8 vector field. So I'm going to upscale that to 16 cubed. So here, by setting it to 16, it will upscale this one to 16, it will keep this one as is, and it will downscale that one to 16. And here, if I scrub the frame slider, you can see there where it's actually useful. It allows me to say, no, I want to start on that one, not at the beginning, but later on. And yeah, so this isn't ideal. Like, you can't do everything using these simpler controls. The really full-fledged thing would require to control the frame range or to handpick even the frames per source asset, but this is totally overkill in our opinion. So currently you can't do that. If you really want to do that, you'll have to do an intermediate step where you export separate frames, or you export a reduced FGA file with less frames, and then re-import that to reassemble your vector field. But this is a quick way to, to quickly set it up for easier scenarios. So let's say I'm happy with that. I hit import. Just before, here you might have noticed that I have this resampling mode, which wasn't available before. Here, so whenever a vector field gets upscaled, you will have access to this resampling mode. So this tells the importer how it should treat border vectors. So when upsampling this 8 by 8 vector field, when using clamp mode, the new voxels that are inserted on the borders will basically duplicate the border voxels of that initial vector field. Otherwise, it will interpolate. If I pick wrap, it will interpolate between the border and the other border as if it were repeating. So here I'll just leave it to clamp, import, and now I have all my frames and the roto wash at the end, which you might have noticed is not exactly like the original one. And this is an interesting thing, because the roto wash, the original one, is exported as Z up, and here all the other vector fields were Y up. So we can actually fix that. Yeah, here you can see it's flipped. So we can actually fix that, and I'll show you how. So I'll pick the same source files, set it to 16, And here in source axis system, if I change that, it will change the axis system for all vector fields. But I have an additional option, which is per file. So when I pick per file, I can specify for the rotor wash that it is in fact left-hand Z up. So now if I import it again, now I have the rotor wash in the proper orientation. So this wraps up this video. If you have any questions or comments on that, don't hesitate to comment down below or to send us an email. Thanks for watching.